You know, one of the great things of coming to trade shows, especially for me, is seeing all the new equipment, right?
Yeah.
You know, and the CMSC is no different. We come to CMSC and there's all sorts of really cool 3D measurement equipment. Well, we had a chance to visit the folks over at Capture 3D. They had a couple different pieces of equipment they wanted to show us, and we're going to show one of those to you right now. And we're at the CMSC show in Snowbird, Utah, and right now we're actually at the Capture 3D booth, and we're going to talk about a new piece of equipment from Capture 3D and GOM. And with me right now is Staton Apple.
Yep.
And what do you do here at Capture 3D?
I'm a sales engineer for Capture 3D.
Fantastic. And what are we going to look at?
Today we're looking at the ATOS Capsule. This is the latest scanner we've released. It is a 8 million to 12 million megapixel structured blue light scanner.
Okay. And what market is intended for, or what market are you seeing the most interest in it for?
The market that we're seeing the most interest and success in, which is what it was designed for, is markets where we have small parts, really intricate, high detail, high complex, where accuracy is really, really important. Where there's a lot of reflectivity, we're seeing a lot of success, and parts where there's a lot of geometry that other measurement systems have struggled with.
Okay, and this is I think you said this is a structured light scanner, right?
Yes, it is.
Okay, and so why don't you just take us through what it does? Talk about the software and the hardware and so forth.
Yeah, so what we have set up here is our base level of automation. This is on a rotary stage, and what we're doing right now is scanning a blade. The big part of the blade analysis stuff that we're going through is the leading and trailing edges, but we can actually do 100% inspection of this blade without contact. It's set up in a reference frame. One of the big things that our customers are doing is setting them up in these so we're not actually targeting or touching the blade itself. This not only saves on your setup time and inspection time, you're also not contaminating the part in any way.
Okay, and how does it interact with the software?
So this interacts directly with the software. One of the unique things about us at Capture and GOM is our software and hardware is all one system. There are no handshakes, we don't party with anyone else, it's all under the same roof. And so the software itself is actually running the automation and the inspection at the same time.
And you're scanning right now, you're scanning a turbine engine blade?
Yes, we are.
Okay, tell us what we're seeing.
So right now, we're looking into, and this is actually a live data set that he's has on the screen right now. On the top left, you're seeing the live camera view, and on the right side, you're actually seeing what's red is what was captured in the last shot.
Okay, so tell me a little bit about the accuracy of the capsule.
The accuracy of the capsule, I guess the best way to demonstrate that would be we just won a competition through GE Aviation Inspection Challenge. There were 51 entries in that total. We won, and the accuracies that were reported with that win on a knife edge were accuracy of 10 microns with repeatability of 5 microns.
Okay, so if I understand this right, there was a competition, the GE competition. I vaguely remember this, and there was all these different companies, basically with the same types of scanners, so structured like scanners, and they went up against each other against a particular artifact.
Yes, there was a standardized artifact that they had, which was actually a knife edge on I think it was a Victorex paring knife, and they said, okay, here's your standard artifact. Everyone uses whatever scanner you want to use, wherever you want to bring it from. We'll take the best results and the most repeatable results.
Okay, so 10 microns accuracy, 5 microns repeatability.
Yes.
Okay, so tell me a little bit about automation. I mean, I see this is on a rotary table right now that's obviously controlled by the computer. So how much automation can you do with the capsule?
I guess that really is going to come up to how much do you want done. So this is the basic form we have on here, which is just a rotary stage, which is called a ROT 640, and the capsule is set up on a manual stand. For a lot of applications, this is fine, but what we're seeing is, as any manufacturing, faster and better. And we roll into what we have is called a scan box. We have a full line of different scan boxes, and basically it's going to be the same setup. It's going to be a larger rotary, and the capsule is going to be mounted onto a robot. And we can adjust that robot size and scan box size on the application. So if your blade's smaller, we size down. If it's larger, up into stators and blisks, even up into huge titanium ones, which we have a lot of success with, we can automate those as well.
Okay, so for everybody who hasn't seen, the scan box is literally just a big box with a robot inside, right?
Absolutely. It's a turnkey solution that we developed to kind of get out of the customized cells. We had a lot of customers that wanted to have something in immediately without any hiccups, solid handshake. So we developed a full line of them down to the 4105, which we can do very, very small parts in, up to a full-size 8 series where we're doing up to full-size body and whites.
Okay. Now let's talk a little bit about the about reporting. Step us through maybe what type of reporting you can do once you've done a scan.
Yeah, absolutely. So we can go through multiple steps in the reporting phase. We can have base level reports up to really, really high level detailed reports, traditional kind of CMM style, if you will. So here's an example of some of the report pages we can generate. This is a color map on our alignment with an RPS1 alignment. This is the inspection with the staggering cord with the same alignment. This is the leading edge and trailing edge positions. This is the thickness. Here's the twist. And here is just a table. So if we don't want a visual, this is more of a numerical that we can get over to the engineers. This is a different alignment with your parallel and bitangential cord. And this is a surface comparison where we align the actual data to the CAD model and kind of can use a color map to check the deviation in the part.
So is the customer able to customize these reports, make them look and feel the way they want?
Absolutely, we can customize this to any of the customer needs and requirements, also third-party requirements. Look however you want, and we can put anything you want onto it. And have it completely saved as a template. You can regenerate it each time.
Okay, and including specific standards, some standards require formats for the report.
Absolutely, it's got 100% customization to whatever the customer could ever possibly want in there.
Okay, well, terrific. Well, Staton, appreciate taking your time with us today and stepping us through. This is the GOM capsule,
Yep,
right?
absolutely.
And by the way, these are available now, right?
Yes, they are. They released. We did a public release as of January this year, and they are available.
Terrific. Thanks.
Thanks. Sorry.
And thanks again to Staton Apple and the folks at Capture 3D for letting us come into their booth and take a look at their products. We are going to actually have another Tech Corner from Capture 3D, brought to us by their Director of Operations, Johan Grout. Later on, a couple weeks, I think. We're
a couple weeks, early in August. Look
Yeah.
out for that one. We'll bring that to you early in August on an upcoming episode of Quality
Yeah, so
Dinosaur.
thanks again to the folks at Capture 3D for letting us do that.